Hello, and today we're going to be doing derivatives of functions implicitly. Here's a 21 question worksheet. I encourage you to try it out yourself before watching this video as it contains all the solutions to all the problems. I especially like question 21 because it is quite a long one, does require a lot. And if you could do that one, then you're definitely fine for any derivative test you need. So we're going to start off with question number one. I will not be going over in detail any of the rules. I'm just going to be applying them. So hopefully you already have a fundamental understanding of what the rules say. Number one, f of x is equal to square root of 2x plus 1 times sine of x squared. I encourage you to have this out with you to follow along. So the derivative of f, we have a product, so we're going to use the product rule. This is a square root of x, right? So we're gonna have 1 over 2 times the square root of 2x plus 1, since that's our inside function. But wait, since we're using the chain rule, we'll multiply by the derivative of the inside, which is 2. And since we're using the product rule right here, we're gonna multiply by sine of x squared plus just the left function times the derivative of the right, which derivative of sine is cosine, and we're just going to write our inside and multiply by the derivative of the inside. Problem number two, f of x is equal to x squared plus 1 over 3x minus 2 times cosine of 2x. So in order to find f prime of x, we're going to use the following method: product rule and quotient rule. How are we going to do that? Well, first we're going to use the product rule. So we're going to find the derivative of this times that plus the derivative of that times this. And the way to do that is first the derivative of the left function is a quotient. So the derivative of the numerator is 2x times 3x minus 2 minus x squared plus 1 times the derivative of the denominator, which is 3, and all of that over 3x minus 2 squared times cosine of 2x. And now, since we're using the product rule, we're going to rewrite the first function and multiply by the derivative of the second. The derivative of cosine is negative sine, and we're going to write our inside and multiply by the derivative of the inside. And this is going to be our answer. Remember, you don't have to simplify it unless you're going to use it again and maybe find a second derivative. That is when you would ideally simplify. Otherwise, it's not necessary. So, what is the derivative of f of x? Well, we have a product, so we're going to use the product rule, and we're going to bring down the exponent, subtract by 1, and multiply by the derivative of the inside, which is 2, and multiply by tangent of the square root of x, plus our first function times the derivative of the second function, which becomes, well, the derivative of tangent is secant squared of the square root of x, but the derivative of the square root of x, which is the inside, is 1 over 2 root x. It's one of those things that I recommend to memorize. The derivative of the square root of x is 1 over 2 times the square root of x. But, I mean, you could always just use power rule. And I believe we're done there. So, problem number 4. And if I do make a mistake, just let me know. It is possible that I mess it up somewhere, but I'll try not to. Of course, it would be good exercise for you if you could even point out the mistakes. So the derivative in this case, we have the product of 3 functions, and one of them is a product. So first we'll focus on that. So the derivative of the left times the right plus the left times the derivative of the right, derivative of cosine is sine. We'll write the inside times 3x squared, which is the derivative of the inside, plus, the derivative of 3x squared is just 6x, and the derivative of negative 2 is 0. Problem number 5. F of x is equal to sine of x squared plus cosine of 2x all over x squared minus 1. So, in order to do this, we have a quotient, right? And first, we'll find the derivative of the numerator, which is, okay, first, how are we gonna do this? Well, let's think for a second. And the derivative of sine is cosine, and we'll just write our inside, multiplied by the derivative of the inside, plus the derivative of cosine is negative sine. And again, same thing, multiply by the derivative of the inside. And this is our derivative of the numerator, and we'll multiply that by the denominator minus just our numerator plus the derivative of the denominator, which is just 2x. And now all of that goes over the denominator squared. Problem number 6. Problem number 6 said that if f of x is equal to x squared minus 1 times secant of x squared all over x plus 1 to find it. Now here's where we have to step back a bit and look at the problem because this simplification can save us a lot of time. So there are certain cases where you can simplify, and when you can, you should. Notice that this is a difference of squares, so we can factor this out. We're still dealing with f of x. We haven't differentiated anything. From secant of x squared all over x plus 1, right? And really, we're just going to cancel this out, and now we just have a product of x minus 1 times secant of x squared. Now we're going to differentiate, and notice how it becomes a lot easier. So the derivative of the left is 1, the derivative of the right. Okay, secant becomes secant of the inside times tangent of the inside times the derivative of the inside 2x plus x minus 1. Um, oh, okay, I see. That's fine. We can just do it in the other order, but yeah, so sorry. The derivative of this one, secant of x squared plus now x minus 1 times this. Sorry. There we go. So the derivative of the left times the right plus the derivative of the right times the left. Okay, there we go. So problem number 7. It says that if f of x is equal to cosecant of 2x times x squared plus 1 to the power of 3 halves. Well, in this case, we have a product, so we're going to use product rule. So cosecant becomes negative cosecant of 2x times cotangent of 2x times the derivative of the inside 2 times our second function plus our first function times the derivative of the second function. We're going to bring down the 3 halves, and we're going to subtract the exponent by 1. And since we're using the chain rule, we're going to have to differentiate the inside, and that'll become 2x. Okay, problem number 8. We are approaching the midway point. So by now, if you haven't really done any of them and you've been looking, now would probably be a good time to start attempting the rest now that you have a feel for what I'm doing and checking with my answers to see what you got. Now, this derivative, okay, it's just straightforward. We're going to get 6x here minus 2 times the derivative of sine of x is cosine of x. Nothing special there. Plus, okay, here's where we have to use the chain rule. So sine of the inside times the derivative of the inside, which is 6x. But nothing crazy. So problem number 9 is this one can be a big one, but not if you do it right. So x plus 1 cosine of x plus 1 squared. Now we're going to use the power rule, so bring that down. The exponent becomes 1, and then multiply by the derivative of the inside, which is the big thing. And to do that, we're going to have to use the quotient rule. So first, the derivative of the numerator is 1, and we're just going to rewrite the denominator minus the numerator times the derivative of the denominator, which is becomes what negative sine of x, right? and all of that over cosine of x plus 1 squared. Okay, problem number 10. Let's start number 10 here. F of x is equal to x cubed times cotangent of the square root of x minus 2x squared. Okay, so what are we gonna do here? Um, okay, so what I would probably do is that we're gonna first treat this as a product, right? So the derivative of the left is 3x squared times just the right plus the left times the derivative of the right. Well, the derivative of cotangent is negative cosecant, right? You should know the squared times the inside. And we'll never forget to multiply by the derivative of the inside, which is just 1 over 2 root x. Again, memorize. Minus, okay, well, that is pretty simple. Power rule, which just becomes 4x. So problem 11, f of x is equal to sine of 2x over x squared plus 1, and all of that cubed. We're going to use our power rule to bring down the exponent and subtract by 1, but also remember we have to take the derivative of the inside, and that's a quotient, so we're going to use quotient rule. Derivative of sine of 2x is cosine of 2x times the derivative of the inside 2, and we're going to multiply by the denominator, and all of that minus our numerator times the derivative of the denominator, which is just 2x, and all of that over x squared plus 1 squared. So now we're moving on to problem number 12, past the halfway point. Actually, yeah, past the halfway point for problem 11. F of x is 2x squared plus tangent of x minus 3 secant of 2x. And you'll notice this one's not too complicated, really. We just use power rule, direct application of just memorize this rule, and minus 3 times. Okay, now secant, the derivative of secant is secant, and we'll write the inside, times tangent, the inside, times the derivative of the inside too. That's the only part where we kind of have to think for a second, but besides that, everything's smooth sailing. So f of x is equal to x squared plus 1 cubed over x squared minus 1. Now we might try to look for a simplification here, but even if we try, we're not going to find one, so we're just going to apply the quotient rule. The derivative of the numerator is just power rule, bring down the exponent, right, and subtract the exponent by 1. Multiplied by the derivative of the inside since we're using chain rule, multiplied by the denominator, minus our numerator times the derivative of the denominator, and all of that just over the denominator squared. Problem 14. We have that f of x is equal to x plus 1 times x minus 1 times sine of x squared. Multiple ways to do this one. One way that's acceptable is just to combine the difference of squares and just use one product rule. Or you could use the product rule when we can use the product rule when we have more complicated like longer expressions. So before I do that though, I should mention kind of the idea behind what I'm doing. Basically, the derivative of f times g times h, well, this is going to be the derivative of f times g times h plus f times the derivative of g times h plus f times g times the derivative of h. So it's just the product rule expanded for even larger functions. Really, we can make the functions just however big we want, actually. So in this case, our idea is going to be first take the derivative of the first times the rest plus the derivative of the second times the rest plus the derivative of the third times the rest. Okay, so let's try that. So this is going to be the derivative of the first is 1 times the rest plus the derivative of the second, which is 1 times the rest plus the, um, well, we'll just write the rest first. And the derivative of the last one is, well, the sine is cosine, and then multiply by the inside. But here you kind of see how um, the expanded product will work, right? So problem 14, or that's problem 14. Problem 15 now is, I will argue, another straightforward one. So it says that f of x is equal to this big expression cosecant of x all over x squared minus 1 squared. Now we're going to use our power rule, right? But don't forget, since our inside is not x, we have to multiply by its derivative. And the derivative of the inside function is a quotient, so we're going to use quotient rule. The derivative of cosecant of x is negative cosecant, cotangent, multiplied by the denominator, subtract by the numerator, multiplied by the derivative of the denominator, 2x, and all of that divided by the denominator squared. So problem number 16, approaching what? 3/4 of the way there? Yeah. Except not really, because problem 21 really does take a lot. So sine of 2x cubed. So the derivative of this, okay, 4x cubed minus 4x plus, okay, this one's pretty easy, hopefully. The derivative of sine of cosine 2x cubed times the derivative of the inside. We drop the exponent, 6x squared. So number 17. Okay, 17, yeah, this one, okay, this one can be quite long. So over tangent of x plus 1 all to the power of 3/2. Okay, so we're going to take the derivative. We're going to drop 3/2 x squared minus 1 over tangent of x plus 1 to the 1/2, right? Power rule. Multiplied by the derivative of the inside, that's a quotient rule. The derivative of the numerator is just 2x. The denominator is tangent of x plus 1 minus the numerator is x squared minus 1. The derivative of the denominator, 1 becomes 0, and tangent of x becomes secant squared of x. So it's nothing crazy, and just the denominator squared. See, nothing too crazy. Problem 18. F of x is equal to secant of x squared times x squared plus 1 squared. F prime of x is going to be equal to, this is the product. The derivative of secant, if you remember, is secant. We're going to write the inside tangent inside and multiply by the inside, the derivative of the inside. And we're going to multiply now by our second function because it's product rule, plus just our original, like second, like left function times the derivative of the right. We're going to bring down the exponent, right? It's like the derivative of x squared is 2x, but we also have to multiply by the derivative of the inside, which 2x. So that's problem 18. Problem 19. This one, mm, yeah, okay. Problem 19, f of x is equal to x plus 1, x minus 1 times cosine of 2x all over x squared plus 1. And I mean, you could, um, I mean, you could try to do something with the algebra here. I wouldn't. I'll just jump directly into doing this. But first, how do we want to group this? Well, actually, we can just use this as one big quotient, and the top we can just use product rule for. So, quotient rule, the derivative of the entire numerator, this one's going to take quite a while. So, derivative of, we're going to use the product rule for three terms. So, this derivative is one, so we're not going to write that. We're just going to write the rest of them. Plus, the second, like the second number, sorry, the second function's derivative is also one, so we're not going to write that. And finally, the derivative of the third function is negative sine of 2x times the derivative of the inside, which is 2. And this is the entire derivative of the numerator multiplied by the denominator minus the numerator times the derivative of the denominator, which is just 2x. But this is the derivative of the denominator, 2x. All of that divided by the derivative, sorry, not by the derivative, the denominator squared. Problem number 20. F of x is equal to sine x to the fourth over x squared plus 1 squared. Okay, we're going to differentiate. We're going to bring the 2 down and write the inside as is. But if we're going to do that, we have to differentiate the inside as well. So this is a quotient, so we're going to use quotient. We'll do the sine of that is cosine multiplied by the derivative of the inside, and we're going to multiply it by the denominator because we're still using quotient rule, minus the numerator times the derivative of the denominator, which is 2x. All of that over the denominator, the denominator squared. Okay, problem 21. This one is quite long, and this one you definitely aren't expected to do. It's absolutely excessive and unnecessary. But if you can get this one, then you're fine. You really don't have to worry, okay? You're absolutely fine if you can get this one. Okay, then here we have an x plus 1 times x minus 1 times tangent of x squared plus secant of x times x squared minus 1, all to the 3 halves. Okay, plus cosecant of x times x squared plus 1 squared over x to the fourth minus 2x squared plus sine 3x squared. Now, this does look daunting, but I can assure you it's actually not as bad as it looks. In this case, before we do anything, we really want to be on the lookout for any type of algebra at all that we can do to simplify. And in this case, I'm going to do the following. This becomes x squared minus 1 because I noticed this x squared minus 1, and this is to the 1, so we'll use our rules to let this just become x squared minus 1 to the power of 5 halves. So you see how that definitely made it better? Okay, so we got rid of what, 2 terms already. We replaced it with 1. Here we can't do anything on the left, and on the right we can't do anything. Now is when we differentiate, okay? So this is a big quotient. So first, the derivative of the numerator, we have to use product rule, right? And in this case, I'm gonna try not to really announce my steps because it's way too much, right? But hopefully by now you should know the drill of what I'm doing. Plus, plus 1 cubed. times cosine 2x cubed times the derivative of that, 6x squared times cosine of the square root of x. Okay, plus x squared plus 1 cubed times sine of 2x cubed times negative sine of the square root of x times 1 over 2 root x, which is the derivative of the inside. Okay, okay, that is quite a lot. So I'm gonna have to move this quite a bit. I'm gonna have to move this, yeah. Definitely gonna have to move this. But it's doable. That's the important part. It's not crazy difficult. So that is the derivative of that. And then we multiply that by the denominator, which I'm going to insert here. This is where the denominator is supposed to go. Tangent x squared times secant of x times here. It's supposed to be inserted times x squared minus 1 to the 5 halves. Okay. Now, minus, we're going to pretty much subtract that. And I guess to avoid confusion, we're still going to put this all in one parentheses, minus all of this. Now times the derivative of the denominator, which, um, I see the issue. Um, this is a multiplication, yeah? It's a multiplication. It didn't get transferred over properly. Okay, yeah. Yeah, that's a multiplication. So we have, so yeah, all of this works. Okay, perfect. So we have now, what is this? So we have those three. So we're going to do the exact same thing to find the derivative of that. God, this is going to be an interesting one. 5 halves x squared minus 1 to the 3 halves times tangent of x squared times secant of x. X squared minus 1 times what? Secant squared of x squared times 2x times secant x plus x squared minus 1 to 5 halves times tangent of x squared times secant of x becomes um secant of x tangent of x. And this is all still one big expression. And then we're done. And all of that should get divided by the denominator squared times tangent of x squared times secant of x. And all of that squared. And now we're going to add that by our second derivative. So we're going to use power rule for that. Cosecant of x times x squared plus 1 times 2 over x to the 4th minus 2x squared plus sine of 3x. And then multiply that by the derivative of the inside, which, yeah, I'm not going to say that there's much algebra to be done there. It's just going to be a quotient. So the derivative of cosecant is negative cosecant cotangent times x squared plus 1 times 2. Well, no, sorry, minus, no, plus, right? Because we're going to take this derivative, cosecant of x this, we're going to multiply by the derivative of this inside, which is 2x. Okay, and this is going to be the derivative of the numerator times the denominator, right? Minus, if we even have like remotely any room to work with here, I'm gonna have to move around some stuff. I'm gonna be honest. It is quite a lot. It certainly is a lot. Yeah. Minus our numerator times times the derivative of the denominator. Right. This one is a lot easier, thankfully. 6x. And all of this becomes over the denominator squared. Squared, and hopefully that should be our answer. For problem 21, this is supposed to be a multiplication, not an addition, so keep that in mind. Okay, so that is that. That was definitely long, but if you can do that problem, and there's a lot of ways to express it, so as long as you're sure that what you did is right, if you can do that problem, you're set, you're fine. Really focus on the other problems though. That one's quite extra, really long computations, really easy to mess up at a single step and ruin the entire thing. Okay, so good luck in your studying, and if you need, I can create another worksheet, although probably won't make a video on that one, but I can make another worksheet with differentiation problems. So hopefully this helped you kind of get a grasp of how to solve some of these problems using the rules that we already